Thanks, Jeff. So I might start with a little bit of some background and some of the recent observations that we've seen probably over the last 20 to 30 years, and then touch on some of the adaptation that has occurred over recent times. So probably a really key factor to my whole presentation is that the water sources that Geodumbing Water utilise in supplying all the farms and towns across our region, for the most part, are climate dependent. So we're reliant on rainfall to produce stream flows, to produce reservoir inflows, and for parts of the region also to produce groundwater recharge. So with changes in rainfall, all these things that rely on the rainfall have a knock-on or see a knock-on effect. So in terms of recent observations, and I'm talking from the 1990s to present, we've seen the average rainfall across the Grampians reservoirs decline. We've seen the annual inflow to reservoirs decline. The inflow season, so the number of months and the months in which we see rainfall and inflows, that's shortened. We're seeing less flow in rivers and streams that don't have dams, so unregulated waterways. We're seeing less consistency of flow, so waterways that may have flowed historically every year may not flow for 2 or 3 years at a time nowadays. We're seeing changes in rainfall patterns and the timing of that rainfall. So I'll give a bit of an example with the Grampians catchments. And up here we have the inflows. So this is water year, July to June inflows to all Grampians reservoirs from the year 1900 up to 2019. We've got this red line here, which is the historic average annual inflow. So that sits around 200 gigalitres or 200 billion litres per year. We've got this squiggly black line. That's a 20-year moving average. So that's that inflow averaged over 20 years and rolled forward. If we come down the other side, we've got the average inflow since 1975. And this is the period that the state government guidelines suggest may be an indicator of current climate conditions. But we've also put in here, and I'll get to it in a few further slides, the average inflow since the year 2000 and since 1997. And you'll notice that this average inflow for the post-97, post-2000 period is less than half of the historic. And that's reflected in this moving average black line that hovers around that historic average until we see this break point around 1996, 1997. And it's a pretty steep downhill trend from there. The only standout is the floods in 2010, 2011 that saw well above average inflow, bumped that moving average up for a 1 year period really, and then it declined. So, it makes sense that it's now sort of plateauing around this average for that period since 97. Now I should get some flashing orange bars. So that represents the 82-83 drought, which probably a few of you in the room will remember. But to put that in context, the inflow that the reservoir saw in the 82-83 drought was almost exactly the same as we saw in winter-spring a year ago. So while that was at the time a really standout event and occurrence, in the present day, that is just normal. That is what we see year to year. So if I pull out just the period since 1996, 97, just a little bit over 2 decades of period there. And I've got the historic average and the respective averages shown on the slides. This suggests that potentially we've seen a step change in catchment behaviour and inflows from that catchment over that period. And as I noted on the previous slide, we've seen that 20-year average now flattening off around that post-97, post-2000 average. So the last 23 years, which I've got here, 20 of those 23 years were less than 50% of the historic average inflow. So only 3 of those years have seen inflow to the reservoirs above or near the historic average. And I've got some data here from Water Corporation in Western Australia, And the intent of this is to show these trends aren't isolated to our catchments or our region. Right across the country in WA, Perth's reservoirs have seen this similar trend in declining inflows. And they've seen probably a more pronounced step change around 1975 and a subsequent step change around the late 90s, early 2000s. But on the whole, it's quite consistent with what we've observed in terms of trends for our own local catchments. Now, if we look at the rainfall side of the equation, obviously, as I touched on, you need rainfall to produce inflows. So what I have here is the recorded rainfall at Lake Wartook since the year 1900. And I've put all the same average lines on it as in the inflow plots. So we've got a red historic average, the average for the period after 1975, after the year 2000, and after 1997. So what I'm going to do is just squash the scale. So now I've taken away everything below 600 millimetres, and this scale now starts at 600 millimetres. So I'm just exaggerating the scale. But what you see is, like the reservoir inflows, a similar trend with the moving average hovering around that historic average, then a decline towards the more recent times. Now, if I put right next to that the inflow trend, you can see while it's not exactly the same, the trend and the shape of that trend is very, very similar. So that really verifies that the change in rainfall is corresponding to a similar change in the inflow to reservoirs. And just so you can have a bit of context on that, the historic average rainfall for Lake Wartook was about 870 millimetres per year. For the period since 1997, that's reduced to an average of 740 millimetres per year. So that's over 100 millimetres reduction in rainfall each year, which translates to quite a substantial reduction in inflow. Now, if we look at just two recent years, 2017-18 and 2018-19, so this is rainfall for the Grampians reservoirs averaged across the catchment. And what you see is a little bit of a different shape from year to year. So the yellow bars being 2017-18, they track quite close to this dashed black line, which is the average monthly rainfall. Now, 2018-19, which is the blue columns, they track similar for the first couple of months, so through July, August. Then they drop away. So the real difference here is that where in the yellow bars, there was quite consistent rainfall through winter, through early spring. In the now flashing purple bars, we saw that in September, rainfall dropped away to be well below average. But we started to get more rainfall in October, more rainfall in November, and had quite a good rainfall event in December. The problem with this for reservoirs and catchments is that through those months, daytime temperatures are warmer, and where those rainfall events are spaced, the ground dries out. So whereas if we were seeing that rainfall through August, September, October, we would probably get quite consistent runoff to waterways, quite consistent runoff to reservoirs. Where it's happening in those warmer months, we're seeing no inflow to reservoirs. So in this year where I've got the flashing purple bars, we saw no inflow from rainfall in November or December. Now, something to also put this in context is these 2 years, the total rainfall for the 2 years was only 10 millimetres difference. The inflow to reservoirs between those 2 years was 35% different. So a small change in rainfall, a small change in the timing of that rainfall can have quite a significant impact on the inflow yield that comes from that rainfall. So this was the most recent, winter period. So historically, July to September are some of the most productive inflow months. And for the most recent period, we saw rainfall around 60 to 80% of average. So you might say it's not the best, but it's not terrible either. But when you overlay catchment conditions and the dryness of catchments heading into this period, and we have that below average rainfall, we saw inflows to reservoirs that were only 26% of average. So again, the change in rainfall, the amount of rainfall, the timing of that rainfall has a much larger impact on the yield from that rainfall. But what's been done to adapt to this? Obviously, we've seen that there's been a really noticeable change in reservoir performance, catchment performance, rainfall, particularly from the mid-90s. And that correlates quite strongly with the Millennium Drought. And obviously, starting in the early 90s, the Northern Mallee Pipeline projects kicked off up north. And that was converting open channels to a pipe system. Saved, I think from memory, it was estimated at the time around 50 billion litres of water per year on average from seepage and evaporation out of channels and farm dams. That was backed up by the Wimmera Mallee Pipeline project. It was a long process, but construction kicked off in around 2006. That then replaced another 17,500 kilometres of channel with a piped system. So by doing that, we went from losing up to 80% of water put into some of the channels to nowadays we lose less than 10% out of a pipeline system. And most of the water that's lost is actually out of the storages throughout the network that bounce supply and demand. So we've gone from a very inefficient distribution system, which probably worked okay when there was a lot of water around, a lot of yield coming out of the catchments. But when that's not the case, we can still maintain quite good security of supply if we can get that water to the users a lot more efficiently. So by pipelining a lot of the region, what we've done is put those water savings back into security for towns, communities, for farms, and to return water back to the environment. Obviously, in the channel days, almost all the water was commandeered to be able to get water to the users, and there wasn't a lot of supply left over to return back to the natural waterways and environment. So if I can show a little bit of what this looked like in terms of water security, don't try and read this, but if you can just take note of the colours. The orange colours are stage 3 water restrictions. Red colour is stage 4 water restriction. The white is no water restriction or permanent water saving rules. So this shows almost all towns across the GW Water region and the level of restriction that they were on from 2002. And I've got through to 2015 because I couldn't fit any more on the slide. But beyond 2015, it's a continuation of permanent water saving rules. But what I'm trying to show by this is that through that Millennium Drought, through those years of low inflows with a channel distribution system, the region was suffering from a water resource standpoint because towns were on severe restrictions. We were struggling to get water to farms. There was mass water carting. Come 2009, pipeline was completed pretty much, back to stage 1 restrictions. 2010, the water resource was boosted by a really good inflow year, floods, and since that time we've maintained permanent water saving rules across the region. And for a little bit of perspective on that, there was more inflow to reservoirs between 2002 and 2005 than there was over the last 3 years. So between 2002 and 2005, severe restrictions across the region. The last 3 years, we didn't have any water resource related restrictions across the region. And I guess you can say adaptation is still continuing in the water space, particularly with current projects, the South West Loddon Pipeline, which is obviously almost completed, and the East Grampians Pipeline, which is currently in the planning process. So that's gone from really trying to improve the efficiency of supply and the security of supply to now extending to supply to areas that were traditionally reliant on local sources or local catchment sources. It might have been farm dams, waterways, and in a changing drying climate, those local sources aren't reliant. So now that we've secured the existing supplies, we're looking to extend those secure supplies to new users. Sorry? Perfect. And I guess while a lot's been achieved in the water adaptation space, the focus of that adaptation has primarily been on water supply efficiency and providing a more secure water supply to areas that weren't previously serviced. There's been a little bit of augmentation in the sense of, in the case of Horsham, you could say adding a bore field for a contingency supply, but across the region, those types of augmentations have sort of been to a lesser extent. Really, it's been the pipeline, which is the main augmentation. But I guess something that might be part of the discussion later today is, well, in the water space, what are the next steps? What are the next considerations for augmentation or adaptation rather?